Good day to you, students. Today we'll be dealing with the topic density. Welcome to class. Definition of density and units. Density is the property of a material. It is a function of the material's mass and volume. Mass of an object is the amount of matter a material is made up of and measured in kilograms. Density also defines how concentrated the mass of the substance is, and it is measured in gram per centimeter cube or kilogram per meter cube. Take note, mass differs from weight. Mass of an object is constant anywhere on the Earth's surface, while the weight of the same object decreases towards the poles. This is due to the effect of acceleration due to gravity on the Earth's surface. For instance, given an equal volume of lead and wood, we can say the lead is heavier than wood, in that, in scientific terms, the density of lead is greater than the density of wood. Definition of density and units. Note, gases have much lower densities than solids or liquids. Can you guess why? Because the atoms in gases are free to move, while that in solids are compacted together. They need to be broken down with the use of energy or heat. While that of liquids, I mean the atoms in liquids are only free to move within a specified container. Density of water is 1000 kilogram per meter cube or 1.0 gram per centimeter cube. We are to drag the following words into the correct boxes to have the first activity for the day. Density is then said to be the ratio of mass to volume for a specific substance. It is measured in kilogram per cubic meters, as we discussed before. It is denoted as D, which is density is equal to mass over volume, or mass divided by volume. Density in itself is represented with the use of the letter rho in Greek. Now, density is the key to floating. All right? Iceberg, that is solid ice on water surfaces, oceans, streams, will rather float in the sea than sink to the bottom. This is because ice is less dense than water. Gold is denser than silver. Pure gold is a soft metal, so silver is generally hardened to make it harder. The amount of silver added dictates the density. Let's check. That's correct. Now, to calculate density. Before the density of a substance is to be calculated, the mass and the volume of the substance is known. Let's try and start with this activity. A sample of ethanol has a volume of 240 centimeter cube. Its mass is found to be 190 grams. What is the density of ethanol? So we solve before we pick our answer. You already know that the density is represented with D, is equivalent to what? Mass over volume. What is our mass in this case? 190 grams divided by volume, 240 centimeter cube. By way of division, 190 divided by 240 or 19 divided by 24 will give us 0.79 gram per centimeter cube. Do we have it as part of the option? Yes. So let's pick it and see. That's correct. So, measuring density. We have to drag the words into the correct boxes. The easiest way to determine or define the density, all right, of a substance is to find the, what do you think that will be? What's in relation to density? Mass and volume of the sample of the substance. For a solid with regular shape, the mass is obtained by placing the object on a weighing balance. The volume, all right, is obtained through measurement, can be through the use of a meter rule. If a meter rule in this case is to be used, that means volume now will be multiplying length altogether 3 times. That will be length times length times length. That will be L raised to power what? 3. Don't forget. To find the density of a liquid, all right? Place a measuring cylinder on a weighing balance. Set the balance to 0. Pour liquid of desirable amount into the what? Cylinder. Read the volume as obtained from the scale on the cylinder. The weighing balance now gives the value of the mass of the liquid. So let's check. Correct. Now let's treat some past questions. You have to calculate the density of mercury. If 500 centimeter cube has a mass of 6.60 kilogram, give the answer in gram per centimeter cube. So with that, density represented with D is mass over volume. Our mass here is 6.60 kilogram, all divided by volume, which is 500 centimeter cube. Don't forget our density is measured in either gram per centimeter cube or kilogram per meter cube. For safety in this case, we are going to change the unit of the mass, knowing fully well that what? 1 kilogram is equal to 1,000 gram. Then 6.60 kilogram becomes 1,000 gram, all divided by 1 kilogram multiplied by 6.60 kilogram. Kilogram and kilogram will go, we are left with 6.60 times 1,000, that will be 6,600 gram. So density now is what? 6,600 gram all over 500 centimeter cube. Don't forget that we are changing the unit of the what? Of the mass. That's what we just did here. So this and this will go. 66 divided by 5. 5 in 6, that's 1. In 16, 3. Remainder 1, that's 10. 5 in 10, that will be 2. So you have 13.2 gram per centimeter cube. Do we have it as an option? Let's pick it and see. All right. That's correct. So we also move on to another past question. A steel block has a mass of 40 grams. It is in the form of a cube. Each edge of the cube is 1.74 centimeter. Calculate the density of the steel. Now, density again is mass divided by volume. We already have the mass, which is 40 grams. Grams is represented with the letter G, small g. Now, volume, in this case, of a cube is L times L times L. That's L raised to power of 3. But we are told that one side L is 1.74 centimeter. That means volume now will be what? 1.74 all raised to power what? 3. So what do we have? We have 5.268 centimeter also raised to power 3. That's cubic centimeter. So density now will be 40 gram divided by 5.268 centimeter cube. Density is equivalent to 7.59 gram per centimeter cube. Let's pick it and check. 7.59 gram per centimeter cube. Okay? That is correct. Let's move on. Now, the masses of a measuring cylinder before and after pouring some liquid are shown in the diagram. We are to calculate the density of the liquid. How do we calculate the density of the liquid in this case? So, the density of the liquid, let me write it as D subscript L is equal to mass of the what? Liquid in the cylinder minus mass of the what? Empty cylinder divided by volume of the liquid in the what? Cylinder minus volume of what? Empty cylinder. So I have the density of the liquid now becomes mass of the liquid in the cylinder is what? Together, that's 217 minus mass of empty cylinder, I have 140, everything in grams, divided by volume of the liquid in the cylinder. If we observe very well, that is 70 centimeter cube or cubic centimeter minus, we do not have any liquid in the first cylinder, so you have 0. That's centimeter cube now, the unit. So here now, 217 minus 140 gives 77, all divided by what? 70 gram per centimeter cube. So that's gram per cubic centimeter, 77 over 70. Now, so let's pick and check. That is correct. Now, we have come to the end of the class for today, but we won't go without dealing with summary for the day by choosing the correct statement. Now, let's analyze the statement for number one after the other, so that we can be able to define which is right or which is wrong. Now, density is the product of mass and volume for a specific substance. Density is what? Product of mass times volume. Is this statement right? It is what? Wrong. Density is inversely proportional to mass and directly proportional to volume. This statement is also what? False. Density is the ratio of mass to volume for a specific substance. This is what? Now, this is correct. So with that, you can say that density is the ratio of mass to volume for a specific substance. Let's check. That is correct. Now, for number 2, you have to choose the correct statement also. Liquids have much lower density than gases and solids. The statement is false. Gases have much lower density than liquids and solids. That is correct because the atoms in gases are not closely packed to that of liquids, which can be a bit free, and that of solid, which is very and very closely packed. Solids have much lower density than gases and liquids. The statement is false. So the correct statement here is that gases have much lower densities than liquids and solids. That is it, very correct. With this, we've come to the end of today's class. And don't forget, do well to visit our website, www.edubbey.com, for more of our interactive notes and videos. Do have a great time. Bye for now.